Okay, so 10.4 is about graphing linear relations, which is basically a fancy way of saying that when we are doing our expressions, we can look at figuring out how something relates from our variable to our expression. So you know how when you have a table, you've got the variable on one side and the expression on the other, and you've got those two numbers? Those numbers act as coordinates for graphing. So that's what we're going to be working on today. Okay, like before, we've got our date. Our title, 10.4, graph linear relations. And our learning outcomes. I can graph a linear relation, and I can describe the relationship shown on a graph. Brenda has a summer job working for a tree planting company in British Columbia. She gets $10 for every 100 trees she plants. That means that if she plants 200 trees, she gets $20. If she plants 300 trees, she gets $30. If she plants 400 trees, she gets $40. The pattern can be shown on a coordinate grid, and that pattern is called a linear relation. So when we're talking about linear relations, it's the relationship between numbers graphed onto a coordinate grid. So on here, in your textbook, you can see on the coordinate grid the relationship between the number of trees she plants in the hundreds, and that is our x-axis. Remember that our horizontal axis is our x-axis, and the amount of money that she earns graphed on the y-axis. So when she plants 100 trees, she gets $10. Our coordinate here, remember how to write coordinates? That first coordinate is 100, because x-axis always comes first, and 10. Okay? X-axis, y-axis. X and y. And this is something you need to remember. We've gone over it before, but it's something you need to remember now that we're coming back to using our coordinate grids. So, how can you determine a pattern on a coordinate grid? The game of detective is played on a coordinate grid. Players try to guess the location of the footprint. The footprint may be placed horizontally or vertically on the intersecting lines of the grid. It is made up of 3 side-by-side points. To find the footprint, you must locate all 3 points. It's basically Battleship, right? Okay, so have a coordinate grid. Label the x-axis and the y-axis from 0 to 6. We're just dealing with the first quadrant, right? Positive numbers. So 1, 2, 3, 4, 5, 6, or if I don't want to have to write all of the numbers out, 2, 4, 6. This distance, this was something that you guys had problems with when we were doing our coordinate graphing. This distance needs to be the same as this distance. This distance needs to be the same as this distance. What I saw a few times were things like this, where you would have one or 2, 4, 6, 8. This distance is only one box, but this distance is 2 boxes. The distance here is 2 and the distance here is 2, but they don't represent the same thing. So you have to have equal spaces between your variables. Okay? So you make a guess of 3, 2. So 3 is first. That means we're looking at it along which axis? X or Y? X. 1, 2, 3. And then 2, what do I do next? Go up 2. So this is my guess. You hit the footprint. So we put a little X. Okay, we hit the footprint. Yay. That means, what 2 lines can the footprint be along? Remember, if we go back here, the footprint may be placed horizontally or vertically on the intersecting lines of the grid. So where does this footprint have to be? What would horizontally be along this? Yeah. So along what line on the y-axis? The 2. So it can be this way. My footprint can either be this way or what? Yeah. Or it can be this way. Okay, so my footprint is either here or here. Your next guess is 3, 3. Where's 3, 3? Yeah. Yeah.
Right above the 2 on that side.
Good. So we guess here, and it's a miss. So we do a 0 to say that we have missed. Could the footprint be along the vertical line through 3, 2?
No, because then it would be like too big. No. It would be like too small.
Okay. Next, you try 2, 2. It's a hit. So we put our little X down. What are the possible coordinates for the last part of the footprint? What's one of them? Yeah.
4.
4 is not a coordinate. Remember, the coordinates have to have 2 parts. You have to have an x-axis and a y-axis. That's fine. 4, 2. Okay, so we think that it could be here. Does that make sense?
Yeah.
Okay, and then the other one?
1, 2.
Or it could be here. Okay, it has to be in a straight line. We already know that our straight line is going this way, so there's only 2 possible coordinates. Okay, if we hit, like we did, we hit the footprint on our first try. How many possible coordinates would we guess in order to figure out where that footprint is? So we've hit this one, right there. Sorry, right there. What do we do next? How many possible coordinates can we do? Yeah.
4, because you could just go above.
Yeah. So we've got, this is a possibility, and this is a possibility, and this, and this. So we've only got 4 guesses at that point. Why do you have to play detective on a coordinate grid instead of on a plain piece of paper? Yeah.
It can help show you, it makes it easier to show you where like, it's more precise, and it shows you where everything is more clearly, it's easier.
That's the thing. It's not even that it's more, that it's easier. On a plain piece of paper, if I put my footprint here, you have no way of relating that to anything on the paper. You could say it's sort of in the middle and a little bit to the right. It's not precise. Whereas coordinate grids, give us very precise placements for what we're trying to find. What are some strategies for locating a footprint? How could you find the footprint? What would you do to begin with? Yeah?
See how long and or wide it is, where you're to start, I think it's 3 wide, that way to keep going.
Okay. You need to know the size of the footprint. So we know the size of our footprints. In the game of detective, it's always a 3 along one line. So you're playing the game. What do you start with? I have a footprint somewhere on this grid. Where do you start? Yeah.
Presumably in the middle, so you can just pick a coordinates in the middle, so you can go 4, 4.
Okay. So basically she's starting with a random guess. That's a miss. What do you do next? Yeah. Yeah.
You could go lower, 2, 4.
Okay. 2, 4 is actually to the side. X-axis first, then the y-axis. Okay, that's a hit. So now that you've got a hit, so the first part, you're kind of doing random guesses. But once you've got a hit, then what do you do? Yeah.
You pick the 4 spots around that hit that you can attempt to destroy them.
Yeah. Your next guess is going to be in one of these spots that is possible for the footprint to be. Yeah.
I feel like it's not going to be to the right because you said it has to be 3 in a row. Actually, never mind.
Okay. Yep.
You could try anywhere, so you could do I guess 4, 4, 5, or 2, 4, 5.
2, 5.
Yeah.
Hit.
Yeah.
Okay. Now, what do you know about the footprint? Yes.
You notice 3 things long, and then we've already got 2, so you just have to hit the last one. And if it's going in a row, then you either have to go 2, 6, or 2, 3.
Yeah. It's either going to be this one or it's going to be this one. Next guess. Yes.
2, 4, 3.
And you have found the footprint. Okay. So your strategy in this is random at first. Once you hit the footprint, then you can have a more precise strategy, because once you hit it once, you've only got 4 possibilities. Once you hit it the second time, you've only got 2 possibilities. So your choices narrow down. So, example number 1. Dr. Seuss often described patterns in unique ways. He once wrote about a pup in a cup and 3 fish in a tree. So, we have our number of pups, we have our number of fish, and we have an ordered pair that is pups and fish. Which one is our x-axis, pups or fish?
Pups.
And our y-axis?
Fish.
How do you know? Yes.
Because it comes second before the first number.
Because right here it has in our order P, F, and we know that X comes before Y. So we have in our table, we're going to copy and complete the table. Let's see, that's going to need to go there. What does it tell you to do? This is example 1. It says copy and complete the table, so we're going to start with that. We have 1, 2, 3, 4, 5 pups. we have 3 pups, 6 pups. If we have, 6 fish. If we have 3 pups, how many fish do we have? You can call out. 9. And if we have 4 pups, 12 fish. And if we have 5 pups, 15 fish. So we have our ordered pair of 1, 3. Our next ordered pair is what? 2, 6. Next, you can call out. 3, 9. Next, 4, 12. And finally, 5, 15. When I am doing my table, because my next part is to make a graph using the ordered pairs in my table, what's my graph going to look like? Is it going to take up this whole sheet of paper? We're going to pretend that I haven't actually written on the sheet of paper yet.
No.
How far do I have to have on the x-axis? Yeah.
Around 5,
Yeah. So I'm going to have to go just past 5. So 1, 2, 3, 4, 5, and I'm going to go a little further. What about the x or the y-axis? How far does that have to go? Yeah.
Around the same length?
No. Look at the numbers. Yes.
16, because you have to leave an extra one.
Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That was me not being careful. So I'm going to extend it down this way. 13, 14, 15, 16. And draw that. And I'm going to hope that I have an eraser. All right, so I have this. I need to label it. 2, 4, 6, 2, 4, 6, 8, 10, 12, 14, 16. So using a graph, what is my first ordered pair going to be? What do I do first when I'm graphing? What is my first ordered pair? Yes.
1, 3.
Okay, so is this where my first ordered pair is going to be? Right there?
No.
Why not?
Because the x goes first.
X first. So along the x-axis 1, along the y-axis 3. So there's my first ordered pair. What's my second ordered pair?
2, 6.
2, 6. So I go to 2 along the x-axis and
The y-axis.
6 on the y-axis. Good. What's my next one? Yes.
3, 9.
Okay. 3 here. 9 there. Next. Yep.
Oh, 4, 12.
Okay. 4 up to 12. Next. Yep.
5 and 15.
5 up to 15. What do you notice about my little dots? Yes.
They're diagonal.
They are diagonal.
Like a straight line.
And they will make a straight line if I had a ruler. Even if I don't have a ruler, they'll make a straight line. Okay? It's just my drawing of the straight line is not so great. So when it says describe the pattern of points on your graph, what can you tell me? How can you describe this? This is some of the stuff that we've already got. Yes?
From in between each point, it goes up by 3 and then 1 to the right.
Good. Okay, so each point goes up 3, 1 to the right. Remember to include your directions. And then what you mentioned earlier,
Oh, goes horizontal, not horizontal, diagonal.
it makes a diagonal line, a diagonal straight line. Okay, this describes our pattern here. And our graph here, or our table rather, describes the pattern in terms of numbers. Now, we've come up with two different ways of describing this. One is using the distances, okay? Up by 3, 1 right. One is saying that it is a diagonal line. But there's another way of describing it that gets at the expressions that we've been talking about. So what is the relationship between the F coordinate and the P coordinate? Try looking back at our table. What's the relationship between the F coordinate and the P coordinate? Yes. Right. So the F coordinate, we've got the is 3 times the P coordinate. One way of describing it. Okay? It makes a diagonal line. To the right. And the coordinates go up 3 and right 1. Of these descriptions, which one or ones are the most precise? Yeah. The first and last. Why?
Because it's easier to follow reading a graph those two, because then you know exactly how to do it rather than just drawing a line upward, because there could be a whole bunch of different kind of coordinates.
So these two give you a more precise explanation of what's actually happening on the graph. But could you draw the graph with just these two pieces of information?
No.
What are you missing? Yeah. Okay, yeah.
The first coordinate?
The starting point.
Yeah.
Okay, so if we took these starting at and added starting at 1, 3, what's the other piece of information that we need? We know our start point. Yeah. Our ending point. Okay, with these two pieces of information, either the first or the last is going to give us enough information to actually replicate this graph. This one, not so much. Okay, so the next example is on page, what page is it for you guys? 376, okay. Armand is 4 years old. His allowance starts at $2 per week. Each year, he will get a $1 per week increase. The graph shows what his total allowance will be after the increase each year. So if you look at the graph, we're going to copy it into our books because we're going to need to increase it. So at 4 years old, he gets $2. At 5 years old, it's a $1 increase. Okay, so this is his allowance. This is his age. They're 6 years old and they're 7, and that's what we have on the graph in our book. It says continue the pattern. Make a table of values for the first 6 values of x. What are we going to do? If it's asking for a table of values, what do we do? Make a table. This is not a table. What is this? Graph. So, table of values. First 6 values of x. So x, what does x represent on the graph? His age, yeah. So x is his age. When he is 4, what's y on the graph? Yeah. His allowance. When he is 4, he gets $2. When he is 5, he gets $3. When he is 6, he gets $4. And when he is 7, he gets $5. What do we need to do in order to continue this? Yeah.
You add 1 to each side.
Okay. And based on the question, which tells us to make a table of values for the first 6 values of x, how many times are we going to have to do that? Yeah. How many more times are we going to have to do that? Yeah. 2. 1, 2, 3, 4. There's the first 4 values of x. 8 and 9 will be the first 6 values of x. And we know that each one is going up by 1. Okay? Now, describe the pattern of points on the graph. On here, if we add our graph, when he is 8, he gets $6. When he is 9, he gets $7. And there we've continued our graph. Describe what's going on here. Yeah.
Is it because it's going up each time, as in he's getting $1 a year each time?
Yeah, so it's increasing by 1, and what's the other part of this piece? So it's going up by 1 each time, and the graph is moving, yeah, to the right. Okay, it's going up 1 and to the right 1. Each point up 1, to the right 1, up 1, to the right 1. So we describe what's going on, the pattern of points. What else do we need? What's that other piece of information that we need in this description?
It starts at 4, 2.
So when we're giving our description of a graph, we need to be precise. We need to tell where it starts. With our other graph, example 1, we stopped. Do we have an endpoint with this one? Not really. Why not? Yeah.
Depends how long he lives with his parents.
I suppose it does depend how long he lives with his parents. But basically, right now, they haven't said until they're 21. So maybe when he's 42, he's still going to be getting an allowance. How much would he get if he was 42? He would not get $43. If he was 42, how much money would he get?
40.
Yeah. $40 a week, which is a lot of money. So, what's another way of describing this relationship? Remember, we have 2 ways of describing that are precise. One is describing the horizontal and vertical distances. The other, yes?
Define y, take off 2 off of x.
Good. It is our, what's that called? Expression. X minus 2. Okay, our y coordinate is our x coordinate minus 2. So from looking at the graph, you should be able to figure out the expression that describes the relationship between your x and your y axis. Yeah?
Would this be like a sort of different way how you find out like the figures of something? Like,
Yeah.
how you
And that actually brings me to one of the things that came up in your journals, is that when you're doing a number pattern, so in this case, our number pattern, if we were going to rewrite this as a number pattern, it would be 2, 3. Actually, that's not even a good one because it starts at 4. There. So what we want in order to figure this out, let's look at this one. What we want in order to figure this out is when your x equals 1. Because you are figuring out the first entry, the first set of fishes is 3. The second set is 6. The third set is 9. The fourth set is 12. When you start up with something like this, you can still figure it out, but you don't figure it out quite the same way. So if we look at the table of values, what do you notice? This is going up by how much each time? 1. Remember, when it's going up by the same amount each time, that becomes our multiple of our variable, in this case x. 1x, we don't write the 1, we just write x. Okay? Then we look at our x, which is 4 in this case, and we see, okay, well 4 does not equal 2, so it can't just be x. What do we do to x? What do we do to 4 in order to get to 2? Here's where you're looking at adding or subtracting. Yeah?
X minus 2.
Okay, you subtract 2. 4 minus 2 equals 2, right? So we check it off. 4 minus 2 equals 2. Good, that one's right. 5 minus 3 equals 2. Sorry, minus 2 equals 3. Okay. 6 minus 4 minus 2 equals 4. Okay. So by checking 3 of them, if you've checked 3 of them and they're all right, you're usually fine. You don't necessarily have to go through and check all of the ones in the table. But you want to check them. You want to check at least 3 to make sure that the pattern holds. What will Armand's allowance be when he is 15? Yes.
$13.
How do you know?
Because it's always
I don't know how to say it.
Yes.
So it's if he's like 15,
Mhm.
it would be 2 less than what his age.
So we substitute 15 for x because x represents his age. Now we have y, or the money that he gets, equals 15 minus 2. And we know that 15 minus 2 equals 13. So he's going to get $13. Okay? Once we know the expression, we can substitute whatever values we want. Just like we did when I said, what would he get when he's 40? Well, the amount of money that he gets is 42 minus 2, which is 40. In the unlikely event that his parents are still giving him a weekly allowance when he's 42. Don't count on it. Do you have any questions?